Understanding the value of SunVault DX, Sunpower's complete energy storage solution. This simple all-in-one storage system includes the hardware and installation, an intelligent control system that's powered by machine learning, ongoing operations and maintenance support, regular reporting to easily track system performance, and the option of a kiosk in your lobby so you can easily share performance metrics with customers, employees, and shareholders. SunVault DX storage is designed to maximize energy cost savings with or without solar. To illustrate how SunVault DX storage saves money by reducing energy costs, we should first explain utility demand charges and times of use. Demand charges are fees utilities charge commercial customers on top of regular energy costs. They're often 30% or more of an organization's utility bill, and the utility calculates them by looking at all days within a billing cycle and then averaging power usage in what are usually 15-minute time intervals. The highest average power usage within a billing cycle is what determines the all-hours demand charge. It's calculated by multiplying that highest amount by an all-hours demand charge rate. If the highest average power usage within a billing cycle is 500 kilowatts and the all-hours demand charge rate is $10 per kilowatt, the customer would be billed $5,000 for all-hours demand charges that month. On top of all-hours demand charges, there are often additional charges assessed for the highest average power usage within certain times of the day. Peak demand charges, for example, are calculated by multiplying the highest average peak period power usage in a billing cycle by the peak demand charge rate. So, revisiting the billing cycle on top of the all-hours demand charges, additional peak demand charges would be added. This means the total demand charges would equal all-hours demand charges plus peak demand charges, which can add up to a significant portion of monthly energy costs. Now let's look at times of use. The peak period mentioned earlier is what's known as a utility time of use, or TOU. TOUs are periods defined by the utility with different rates and pricing, and in addition to affecting demand charges, they also affect energy prices. TOUs vary by season and even by type of day, like weekday or weekend. Let's see how SunVault DX storage intelligently analyzes facility load, solar production, TOUs, and utility rate structures, including demand charges, to save money. This graph illustrates an example energy load profile for an office building. It shows the amount of power used from the utility grid over the course of a typical sunny workday in July. It ramps up as workers start coming in, continues to climb into the afternoon, the hottest time of the day when the AC system is hard at work, and then slowly declines until late in the evening. To simplify, let's assume every day during the utility billing cycle looks similar to this. Therefore, the facility's highest average power usage for the month will be the maximum load illustrated here on this typical day, which occurs right around 2 p.m. and is 538 kilowatts. Let's say the all-hours demand charge rate is $18 per kilowatt, which calculates to $9,684 per billing period and would show up on this month's utility bill. But there's a time of use factor here as well. The peak period for this particular utility rate structure is from 4 p.m. to 9 p.m. in the evening, and the highest average power usage within that time frame occurs around 4:30 p.m. and is 420 kilowatts. With a peak demand charge rate of $2 per kilowatt, peak demand charges amount to an additional $840 per billing cycle. So the total demand charges would equal $10,524 in the month of July. Now, before we add storage, let's see how a solar installation alone could reduce this cost. As you can imagine, it has a significant energy impact. The red line indicates the utility grid energy load with solar, which begins to drop dramatically when the sun comes up and the solar system starts generating energy. This red line is what the utility meter will see with solar installed, descending below 0 kilowatts just after 9 a.m., which indicates net metering is available for this customer. Net metering is where excess energy is sent back to the grid for credit on their utility bill. So, solar has a rather large effect on the overall energy load, even to the point of exporting energy in the middle of the day. But as you'll see, it doesn't have as significant of an impact on demand and demand charges. The new highest power usage for all hours of the day now happens around 6:30 in the morning and is 378 kilowatts. The highest power usage during the peak time of use period occurs around 8:30 p.m. and is 250 kilowatts. When we do the math based on the previously stated demand charge rates, they now add up to a little over $7,300 this month, which represents about $3,200 in demand charge savings with solar installed. Which is great, but our SunVault DX storage solution can save you even more. Let's see how. SunVault DX storage system's intelligent control system works behind the scenes to analyze a wide variety of complex, ever-changing data. It then automatically adjusts and orchestrates the storage system components, resulting in maximum energy savings. Here's what's going on in the background. With SunVault DX storage installed, which is represented by the blue line, the system uses the previous day's energy to discharge and keep all hours demand down before solar starts generating energy. The dark blue area indicates that SunVault DX is discharging, and the black line shows what the utility meter sees. After the initial discharge to cover the morning ramp, solar starts charging the storage system, which is represented by the lighter blue-colored area. SunVault DX is fully charged right around midday, and since the storage system now goes idle, the site starts exporting energy back to the grid, just like it did with the solar-only example we just saw. When solar energy production is down to the point where the customer would need to use grid energy during the peak rate period, SunVault DX storage discharges once again to keep peak period demand at zero. Once the peak rate period ends, the batteries discharge just enough to keep the demand at the all-hours level set earlier in the day, and the remaining charge is saved for the following morning. The highest all-hours demand is now only 222 kilowatts, and there's no need to pull any energy from the grid during peak hours. SunVault DX storage works together with solar to zero out the peak demand charges, something neither solar nor storage could do on their own. In fact, this customer is even exporting during a portion of peak time, which is very beneficial when net metering is available. Net metering notwithstanding, with solar and SunVault DX storage, this customer is now only paying $3,996 in all hours demand charges, and no peak demand charges at all. So the total demand charges this month are now under $4,000. Let's summarize what we just saw. The original demand charges for this facility in July were over $10,000. After solar was installed, the customer saved $3,220. The SunVault DX storage was able to save an additional $3,308, for a total savings of over $6,500, reducing the original demand charges by about 62%. Keep in mind that this example simulates a perfectly sunny day in the middle of July. If a day turns out to be cloudy, SunVault DX storage can help improve the value of solar by filling in the gaps when the system isn't producing energy, adapting in real time to maximize cost savings. SunVault DX storage simply and effectively delivers more value than solar alone. Another way customers can save money with SunVault DX storage is by shifting when they buy energy from the grid over the course of a day. Let's see how that happens by re-examining the load graph we used for demand charge savings. Instead of focusing on demand, however, we're looking at the amount of energy pulled or imported from the grid, as well as the energy sent back or exported to the grid via net metering over the course of this typical July weekday after solar has been installed. This energy is measured in kilowatt hours and is generally represented by the areas above and below the red load post solar line and the 0 kilowatts of average power graph line. This utility offers full retail net metering, which means the import and export prices for electricity are exactly the same. And just like with demand charges, the utility applies a different rate for electricity during the peak and off-peak time of use periods. So, the total cost of energy for each day's individual time of use periods equals the amount imported minus the amount exported multiplied by that period's energy rate. In this scenario, the customer would be paying $90 in off-peak energy costs and $60 in peak costs for a total of $150 on this typical sunny summer day. Now let's add SunVault DX storage to the equation. Buy low, sell high. That's an easy way of thinking about how SunVault DX storage can save money in addition to any demand charge savings. The customer is buying more energy than they normally would when SunVault DX storage is charging, and is essentially selling energy when it's discharging by buying less than they normally would, or possibly even exporting energy back to the grid. So the savings from SunVault DX storage results from allowing the customer to buy energy when prices are low and sell it when prices are high. In the example here, we see SunVault DX storage charging or buying 1,300 kilowatt hours during the off-peak time of use period, when energy is least expensive. SunVault DX storage also discharges or sells 400 kilowatt hours during the same low-cost off-peak period. If you recall, the reason it's discharging or selling when energy is priced lower is to keep the demand level down for more substantial demand charge savings. The net result is a purchase of 900 kilowatt hours at the off-peak rate of just 10 cents per kilowatt hour, or $90 in off-peak energy costs on this day. There's a different story to tell during the more expensive peak rate period. SunVault DX storage doesn't charge or buy any energy during this time of use. Instead, it only discharges or sells it, 700 kilowatt hours to be exact, which calculates to $210, or 700 times the peak period rate of 30 cents per kilowatt hour. By subtracting what the customer pays for energy during off-peak hours from the energy credit they receive from discharging during peak hours, the total savings is $120 on this typical summer day. Multiply that by 30, and SunVault DX storage would save this customer $3,600 during a typical summer month. This is additional energy savings on top of the energy savings coming from solar alone, and doesn't even take into account any demand charge savings SunVault DX storage may also deliver. In summary, SunVault DX storage is a simple and complete energy storage solution designed to maximize customer savings with or without solar. By intelligently analyzing utility rate structures and system data, SunVault DX adapts in real time to lower demand charges and reduce overall energy costs, delivering more value than solar alone and even helping to amplify its benefits when it isn't a perfectly sunny day. The result? Customers save a lot of money. But what else would you expect from Sunpower, the only solar company that's been helping customers save money for over 3 decades?